Oh my gosh. I'm so glad that your guys' conversations don't come up on my videos because y'all are weird. So, you guys recently watched a video about functions, and I'm guessing most of you don't remember much of it, which is okay because we're going to talk about it again. We're going to start by talking about relations because functions are relations. And functions are always relations, but relations aren't always functions. It's like a square is always a rhombus, but a rhombus isn't always a square. So we are going to start with talking about relations. And relations are kind of what you would think they would be, right? They're like how things are related to each other. A lot of times they're most often represented as a set of ordered pairs, right? And they can be resented. I'm holding a resentment against these ordered pairs. Represented, they can often be represented as, well, in terms of a table, or they can be mapped. They can be graphed. But they're usually expressed, all those things can be expressed in the form of an equation. That's how we see them most of the time. Now, a table you guys have seen, right? You got your X, Y, you got your 1, 2, 3, and here you got your 5, 6, 7, or whatever. Relations, not notations. Now, apparently, that's my bad. If that looks like rotations, that's my bad. And basically, you've got this set of X values, right? And we call those the domain, right? Any possible thing that X can be is your domain. And then you have a set of Y values, right? In this case, look, this is our set of X values. This would be our domain, right? Domain's considered our independent variables, right? Domain determines what your output is going to be, right? Our X, whatever we put in for X, determines what our Y is going to be. Like if you have a question, I was trying to write it on my paper. So if I have a problem that's like Y equals X plus 1, my independent variable is X, right? Because X is going to determine what we get for I, what Y equals, right? Whatever we put in for X is going to change what our Y is. So X is considered to be our domain, and it is our independent variable. Y is considered to be our range. Set of Y values is the range. Now, I'm not going to go too deep into this. I'm not giving you any homework on domain and range, but I really want you to understand what they are, right? Because the domain and range can determine whether or not something is a function. So if I looked at the domain of this problem right here, there's no bounds on what I can make X, right? I can input absolutely any number I want for X, right? There's nothing there's no limits to it because it's X plus 1. I can add anything I want to 1, right? and I'd still get a y output. So in this case, if I looked at this specific problem, my domain would be negative infinity to infinity, or we could say all real numbers, right? Could be any number I want it to be. My range depends on what my x is. And in this case, my range could also be all real numbers because I can put in any number for x. My y is just going to be one more than that, right? So that would also be all real numbers. But that won't always be the case, right? If I have, say, a problem like y equals 2 over x, there's one thing my domain can't be. What can my x not be ever in a fraction? What can I never have as the denominator? What's that one number we can't divide by? Because this is saying 2 divided by x. What's the one number? Look at all of you throwing it in there. I love that, right? X can't be 0 in a denominator. We can't divide by 0. So in this case, my domain would be all real numbers except for 0. Algebraically, we'd write that as negative infinity to 0 in union with 0 to infinity, right? It's saying that we're everything in the world to the negative in that direction, but we stop here at 0. We don't include 0, but we start here at 0 without including 0 and go all the way to positive infinity, right? So my range is going to be a little limited too, right? Because it can be anything that I want it to be without ever being 0, right? My range is going to be the same because my output, the only way to make a fraction 0, right, is to divide into 0. And you can't divide by 0. So, yeah, it would be undefined. But our range isn't undefined. It's only undefined in that one spot, right? Our domain is not undefined. It's only undefined where 0 is. The rest of it is perfectly defined. So our range is going to be, I'm not going to write it out. I'm just going to make an arrow that it's the same. Sometimes you could see it in terms of a graph, right? Like if I have, say I'm graphing something like, if I'm just graphing a line, right? If I'm graphing a line, my x's are going to the left forever, and they're going to the right forever. So I can go, okay, my domain is all real numbers, right? Negative infinity to infinity, it can be anything. But my y has that same thing. It's got an arrow pointing all the way down forever. It's got an arrow going up forever. So my range is also negative infinity to infinity. But sometimes that's not going to be the case, right? Sometimes, say if I'm graphing a parabola, which kind of goes like this, and we can call this 1, right? We can call this on 1. My domain can still be anything, right? I have an arrow going to the left forever and ever, and I've got an arrow going to the right forever and ever. So my x values can be anything I want. I can put in any x I want. My domain is going to be negative infinity to infinity. But my range, that has limitations, doesn't it? And you can look at the graph and see there is nothing on y under 1, right? Everything is 1 and higher. And I can tell you why, because this is the graph of y equals x squared, right? So anytime I square a negative number, it becomes a positive number. So I'm never going to have a negative y on this, right? So if I look at this, I'm going to say that my range starts at 1. It's even including 1, right? It's got a dot on there. And it's going to go up forever and ever. It's always going to go into positive infinity, right? It's never going to get below. Now, I'm not giving you any range and domain problems in your homework tonight. It's all going to be evaluating functions. So we are going to get to that part. But I just want you to kind of understand what your domain and range are, because it's going to come up again and again when we're talking about algebra. The part that we are going to move into now is the beginning of functions, right? And like I said, a function is a relation. It is always a relation, but a relation isn't always a function, because functions have certain rules that they need to abide by. One is, it is a relation where each input, which I like to think of as x, because usually we're on a Cartesian plane, so we're dealing with x and y. So where each input has one and only one output, which is our y. We like to say that y is dependent on x. It also, so if you look at it in terms of a set of points, right? Say I have a set of points, and we'd be like 1, 2, 2, 5, 3, 9, 4, 6. You can tell if a set of ordered pairs is a function by looking at your x values, right? First thing you want to see is, do they repeat? Do I have more than one x with the same number? So here I have 1, 2, 3, 4. My x's don't repeat. So I can move on and just automatically say this is a function, right? As long as my x don't repeat, I don't have to worry about it. If my x's repeat and they don't repeat to the same y value, then it's not a function. So if I have 1, 2, 2, 5, 2, 9, 4, 6, this is no longer a function. The first thing I'm going to do is I'm going to look, do all my x values have are they all different? Here I have 1, I have 2, I have 2 again, right? That doesn't necessarily mean it's not a function if I have 2 represented twice. But if they don't have the same y value, it's not a function, because our input has to have one and only one output. So if my input is 2, it has to always kick back a 5. If my input is 2 and then it kicks back a 9 within that same set, not a function. Make some sense? And we can show that graphically too. And I did something fun today. I thought, hey, why do you keep drawing graphs when you could just like have one on hand for you, right? So if I have the graph of a line, right? Any graph to be a function, any equation to be a function, it would have to pass what we call the vertical line test, which means that I can drop a vertical line anywhere into the graph of that equation, and it should only cross it at one point. Here it crosses at one point, here it crosses at one point, right? As long as it only crosses at one point, it's a function. This here is a function. right? This, I love this little thing right here now where I can just do this and I can make it bigger if I want. So what if we graphed a parabola, right? Parabola, you guys might remember it. You'll definitely get to know it really well in Algebra 2. If I drop a vertical line into this, it's still going to be a function, right? There's nowhere I can drop it. What if I do it as, come back over here. I got to get used to this. I'm not used to playing with these things. What if I have a parabola going like this off of the y, like the y equal y squared? If I drop a line into that, it's crossing in two spots, right? Not a function. Circle, not a function. Square, not a function. Ellipse, not a function, right? Certain things you can look at and automatically see that they're not a function. Sometimes you'll get a graph where it's just I want to play with graphs now because I have this little thing. I don't even need to show you all of these, right? But this is fun for me. Sometimes you won't even have like a curve to it, but you could see like if I have a point here and a point here and a point here and a point here, I know from this one that they share the same y, right? The same, this x has two different y values. So it's not a function. So I don't want to spend any more time on that because I'm not showing you any of that on your homework, right? I just wanted you to kind of understand like how we can determine whether or not something is a function. Every x input has to have only one y output. It's the most important part of functions. We have things that we call function notation. You guys have probably seen it before. But all function notation is if I have y equals 2x plus 7, right? And I'm writing it in function notation, our y becomes what we call f of x. And it's not f times x, and I know that that's really something instinctual that you kind of have to get rid of because you're used to something on the outside of a parentheses being considered multiplication now, but in this case, it's not a multiplication. It is just a name of a function. The function's name is f. Its input is x. So we're saying the name of this function that we call f has an input of x. And that x, the relation that's happening to it is we're multiplying that x times 2, and we are adding 7 to it. And we will do that to any value of x that we come across, right? So x is our input value, our domain, and y is our output value. And what you're going to be working on in your Delta math is evaluating functions, which means that we're going to give you a value for that x, and you're just going to plug it in and see what you get, right? So in this case, we've got f of x equals 2x plus 7. And if I wanted you to evaluate that function, example, evaluate, I'm trying to use the language that you will get when you're doing these so that you recognize. Evaluate f of x equals 2x plus 7 at f of negative 3. All that means is I'm going to take negative 3 and I'm going to plug it in wherever I see that x. Right? I'm going to go, what is f of negative 3? And when I write it this way, it means f of x when x is negative 3. That's my input. So I'm going to go 2 times negative 3 plus 7. When I am putting something into a function to solve it, I always put it in parentheses because I don't want to change the operations that are happening, right? Here I have 2 times x. If I just put this in as -3 without the parentheses, it would look like 2 minus 3 instead of 2 times -3. So I always try and keep those in parentheses no matter what I'm inputting because it helps me keep the signs in order and the operations correct. And it really does help. Get into the habit of doing it. It'll really help you down the road. Most people mess up when they're evaluating functions by losing track of that stuff. 2 times -3 is 6. Sorry, it's -6 plus 7, which is just 1, right? And so all of your homework today is going to deal with evaluating functions. So we're going to do a couple of them, right? So if I have f of x equals -5x minus 14, or I could have g of x. We can call a function anything. In this case, I'm calling it f. It's the standard, is the gold standard is f, but you'll see them as g or h a lot of times, especially if you're using more than one function together. You want them to have different names. Equals -x squared plus 9x minus 1. So you're going to be asked to evaluate functions when, say, evaluate f of -9. And it just means we're going to take our f function and we're going to plug in -9. So I'm going to go f of -9 equals -5. Well, my x, parentheses, becomes -9 minus 14. -9 times -5 is positive 45 minus 14 equals 31. I could be asked to evaluate g of what? -7. This is an important one when you think about it, because if I am doing, I keep wanting to write f, g of -7, if I don't put this in the parentheses, I have a negative right here on the x. So I want to make sure that my negative is still on that -7 when I do it. Plus 9 times -7 minus 1. Because what's going to happen here is when I square this -7, -7 times -7 is a positive 49, right? But we have to still put this negative on it at the end, so it becomes -49. -9 times -7. What is 9 times -7? What's 9 times 7? Is that 63? Thanks. I'm a math teacher. I should have known that. Minus 1. Now, these are all negative, right? So I'd look at that as minus 50. That's minus 113. Well, let me check does the f of x stay in the final answer? F of x and y are interchangeable. When I'm dealing with functions, I always leave it as an f of x. If you're delta math, like we can always go look at delta math and see how they want it done. It might tell you f of x equals and then give you a box. If it already gives you that, you don't have to write it, just put in the answer. If it doesn't give you that, then you definitely want to. Well, I think that's really all I've got to show you in terms of this right now, unless anyone has some questions about it. You might get something like this in your more complex ones. So let me show you. Like, we'll use the same two equations here. What if I have a problem like, let's use a different color so they're not all blending into each other. What if I have f of 1 minus f of negative 4? It's a good question, right? Well, we can figure that out. F of 1 would be, so we want to make that a 1, right? We're just going to find our answers to those and subtract them. F of 1 equals minus 5 times negative, I don't know why I want to make that negative 1, minus 14. And then we have f of negative 4, which is negative 5 times negative 4 minus 14. This is going to give me negative 5 minus 14, which is negative 19. This is going to give me positive 20, right? 20 minus 14, which is just 6. And so what do we wind up with? We wind up with negative 19 plus 6, which is negative 13, right? We can solve them each individually and then just subtract their answers, right? F of 1 equals negative 19. F of negative 4 equals 6. So we can just go negative 19 plus 6. Actually, it would be minus 6, wouldn't it? Because we're asking for minus. F of 1 minus. So don't even pay attention to that. We've got negative 19 minus 6, right? Because it's f of 1 minus f of 4, f of negative 4, which is negative 25. I feel like somebody should have caught me on that one, but I'll let you go on it because it's early in the morning still. Any questions? If not, I'm going to stop the recording. I mean, you could still ask questions after I stop the recording, but they won't be in the video now.